Hi, welcome to another video short on limits. Today we will be evaluating a quotient that involves limits. Now if you ever get a quotient that involves limits, there are two techniques that you can use. There's a quick method and a more precise method. Both will give you the same answer. But the more precise method will give you a deeper understanding of why the quick method works. Plus, it will make you a math teacher just a wee bit more proud. Now, when you have the quotient, if the degree of the numerator, that is the term that has the highest value on my variable, in this case it would be 3, if the degree of the numerator is larger than the degree of the denominator, then as x goes to infinity, so would our function. But if the degree of the denominator was larger than the degree of the numerator, my denominator would go to infinity faster than my numerator, and my function, when I take the limit, would go to 0. But if the degrees are the same, a nifty little technique will demonstrate how by just looking at the function you can determine what the limit is. So let's look at the quick method first. So since the degree of my numerator is 3 and the degree of my denominator is 3, those are the only terms I need to look at. All the remaining terms really do not play a role as x goes to infinity, so I can actually omit them. So my quotient is really looking at 2x cubed and looking at 3x cubed. In other words, 2x cubed over 3x cubed. Now I can cancel out the x cubes, just leaving me with 2/3, and that in fact is the answer to this question. This is what the limit is evaluated to as x goes to infinity. So you can actually look at the expression and immediately, since the degrees are the same, just look at the coefficients in front of those terms that have those highest degrees, which are the same, in this case 2/3. Let's now look at a more precise method to see why this shortcut method does in fact work. So, like any time you obtain a limit, the first thing you should always do is plug in this case, plug in infinity, and you'll notice from our infinity rules that this is infinity over infinity, which is indeterminate, which just means, yes, we get to use algebra. So let's just clear off our screen. So look at all the terms, determine which term has the highest degree, and make a note of that highest degree. And that's going to be very, very important for us. So in my numerator, the term that has the highest degree is 2x cubed, and the degree is 3. Likewise, in my denominator, the term that has the highest degree is 3x cubed, and the degree is 3. And since both degrees are the same, then I can simply divide both the numerator and the denominator by x with that degree. In other words, I'm going to divide my numerator by x cubed and my denominator by x cubed. Now I find it's easier to multiply by 1 over x cubed rather than divide by x cubed. I make less mistakes. So I'm going to multiply both my numerator and my denominator by 1 over x cubed. Now I'll just rewrite it this way so it's easier for us to see how I distribute 1 over x cubed across my numerator and my denominator. So we'll do that. I'll do some house cleaning. I can cancel out x cubes over x cubes, and I can take an x squared and divide that into x cubed. In other words, when I simplify, I get something that I'm really looking for. That is terms, quotients, that have a value in the numerator and a variable on my denominator. Now as my variable goes to infinity, my denominator will get larger and larger while my numerator remains fixed. And that is very important, because when that scenario happens, the terms will go to 0. For example, the term 99 over x, as x goes to infinity, that term will go to 0. Likewise, 1 over x squared, as x goes to infinity, x squared goes to infinity even faster, so that term goes to 0. And 4 over x cubed, yep, you got it. That term also goes to 0. And 5 over x, that term goes to 0. And 1000 over x cubed, even that little beastie goes to 0. So when I evaluate my limit, my expression just turns out to be 2 plus 0 minus 0 plus 0 over 3 plus 0 minus 0, which of course is just simply 2/3, the exact same answer I had when I used the quick method. Hopefully this was helpful for you. Thank you for watching.